Sliding or shifting the graph of a function f of x left or right is given by f of x minus h and is called a horizontal translation. If h is greater than 0, then the graph of f of x slides right h units. If h is less than 0, then the graph of f of x slides left h units. Consider f of x equals x squared, which is this graph in red here, so x squared. Two of its transformations, g of x in blue is f of x plus 2, so this is f of x plus 2, and in yellow we have h of x equals f of x minus 3, so this is f of x minus 3. There. The graph g of x, the blue one, is the result when f of x slides left 2 units, because 2 is negative h, because we have a negative sign there, which means that if we put in negative 2 for h, this cancels out and becomes a plus sign. So when you actually see x plus 2, that means you're moving to the left. And if h itself is less than 0, then this negative sign here will remain. So when you see x minus 3, that means you're moving to the right 3. Use the function f of x equals the absolute value of x for each problem below. Write a rule or formula for the new function g after the given translation. Alright, so we have our, in red here, we have absolute value of x, and here we have our absolute value of x minus h in blue. So shift the blue graph left or right as described. So we'll start here. We'll move it right 3 units, and that will be g of x equals the absolute value of x minus 3. So when we move it to the right 3, we have x minus 3. Now when we start here and we move it to the left 1 unit, we get absolute value of x plus 1. When we move it to the left 4 units, we get absolute value of x plus 4. And finally, if we move it to the right 2 units, we get absolute value of x minus 2. Use the function f of x equals x squared plus 2x for each problem below. Write a rule or formula for the new function g after the given translation. Alright, so we have here in red x squared plus 2x, and here we have our new graph g of x, which is going to be x minus h squared plus 2 x minus h. So wherever we see x here, that x will become x minus h. So we're going to move it 3 units to the right, so 1, 2, 3, and this will be x minus 3 squared plus 2 times x minus 3. Alright, if we start here on the red graph and then we move left 4 units, 1, 2, 3, 4, now we have x plus 4 squared plus 2 times x plus 4. If we move it to the left 6 units, so 2 more units, then we have x plus 6 squared plus 2 times x plus 6. And finally, if we start here and then move it to the right 5 units, 1, 2, 3, 4, 5, that would be x minus 5 squared plus 2 times x minus 5. Let f of x equal 6x minus x squared. Its graph is displayed on the right. The function g is given by g of x equals f of x minus 3. Alright, carefully sketch the graph of g of x on the grid to the right. Alright, so when we see x minus 3, that's going to give us a horizontal shift to the right 3. So we have this point here, which is 3, 9. We're going to add 3 to the x coordinate, 1, 2, 3. And it will now be at 6, 9. So the vertex has moved over 3 to the right. We also have this point here. So we'll move this point, 1, 2, 3. And we have this point, 1, 2, 3. So we've moved over all of our points, and now this is what our new graph looks like. Something like that. Write a formula for g that does not involve f. Alright, so we have 6x minus x squared, and we're just going to replace every x here with this instead. So it becomes 6 times x minus 3 minus x minus 3 squared. Alright, so we see our new drawing here, and we have 6 times x minus 3 minus x minus 3 squared.